something embarrassing.
Okay.
No.
Forgot to record the first example for you, Liz. Larry says hi, she misses you.
Me too.
Oh, and Taylor does too.
I miss her more. More.
Larry misses you more.
Yeah,
Okay.
more.
Um,
Yes, more.
I miss you the most, so therefore I'm the favorite. The second example. So again, we're gonna try to rewrite what we can in terms of sine and cosine first. And that's not necessarily the best way to go about it. There's going to be time, like the more that we do this, you guys are going to get used to like, oh, this is probably going to be faster. There's multiple different ways to do these problems. You're not always going to have the fastest way, and that's okay. As long as we get there in the end,
Doesn't matter.
it doesn't really matter. Okay. So again, though, on this one, I would start by replacing, here we have a tangent, cosecant, secant. I would start by replacing these with their sine and cosine counterparts and see what happens. There might be, like I said, there might be a better way to go about this, but I don't really know yet. Okay, we just start plugging stuff in and see what happens. So I would replace the tangent squared with, that's going to be sine squared over cosine squared. Okay, and so our powers of trig functions too, because tangent is sine over cosine, tangent squared is sine squared over cosine squared. Or if we had tangent to the fourth, that would be sine to the fourth over cosine to the fourth. Like those powers are going to stay with those things. Does that make sense? Okay. So I'd start with the sine squared over cosine squared, and then times cosecant is the reciprocal of sine. So cosecant squared would be 1 over sine squared
Oh my gosh, I actually.
minus 1. That's all just in the top of that fraction. We are going to have so many fractions and fractions here. It's going to look gross until we can start simplifying things. Okay, now secant squared is the reciprocal of cosine squared. So this I would change to 1 over cosine squared theta. At this point, it looks gross.
Yeah.
But
So we could cross out the sine squared.
in the numerator, the sine squareds will cancel out.
But then won't the cosine squared cancel out?
No, because of that minus 1.
Oh, wait, the one on the top of the cosine?
But it'll, yes, eventually,
It'll
kind
get
of
there.
will. So once I cross out my sine squareds, then what I have left up there is 1 over cosine squared minus 1. So again, that's my numerator. I'm going to do this all in one step here. Rather than rewrite my denominator as the 1 over cosine squared. Again, because I'm dividing by a fraction, I don't want to do that. I want to multiply by its reciprocal. So we're going to take this whole numerator and I'm going to multiply it by cosine squared over 1.
The numerator is the top, yes?
Mm-hmm.
Oh, never mind, I see it now.
So, and I made sure to put my numerator in parentheses because there's 2 terms there. When we are multiplying by that cosine squared, I have to multiply both of my terms. I want to distribute it to both of those things. So we're going to distribute our cosine squared to the 1 over cosine squared and the minus 1.
We get cosine cubed.
No, we don't. They cancel out.
fourth.
Calm down. If it was a cosine squared on the top, we would.
Oh, I
But
see.
because I have a 1 over cosine squared times cosine squared over 1, they cancel and we just have 1. Minus cosine squared times 1 is cosine squared. Most people would be tempted to leave it right here.
Oh,
Those people are
stupid.
wrong. They're not stupid, but they're wrong. Because we want it down to a single term.
Then what happens to the little -1 in the parentheses? Because when you multiply that times that, it cancels out, then we just have 1. But then that little -1, what is that?
What's 1 times cosine?
Cosine.
Cosine. That's that
Oh.
one. Okay, we've got this down to a single trig function. It's in terms of cosine, but I still have two terms. We don't want two terms. We want it down to one thing. Okay, this is part of the Pythagorean identity. Anytime you see one of these things squared, cosine squared, sine squared, tangent squared, whatever, those are going to be part of the Pythagorean identities. Okay, so cosine squared, this is going to come from the first one that we did, that was sine squared plus cosine squared equals 1. If I try to rearrange that so that it looks like this 1 minus cosine squared, that would be the same as if I subtracted my cosine squared from both sides. And I get sine squared equals 1 minus cosine squared. Well, so now I know that 1 minus cosine squared is the same thing as sine squared. That is my final answer. All of that stuff up here simplifies down to simply sine squared. That's weird that the two that I chose to do both simplify down to sine squared.
Yeah.
That wasn't planned. Okay, and again, there's multiple ways to go about simplifying all of these. There is potentially a best way that's going to be the fastest route to get there, but it's not necessarily the only way to do it. Okay, let's go for this secant over sine times 1 minus cosine squared.
Are you, okay, good.
I'm so excited for chicken strips.
Oh my gosh, calm down, Mary.
Oh my god.
Beeping at us.
It's cussing us out.
So what do you think is the first step that you would want to do here?
Put
Oh,
the
gosh.
cosine over 1.
Do what now?
Put the cosine over 1. No.
Not yet.
Wait, oh, that's right.
When we,
I was thinking,
when we put the secant into something.
wait, what if we multiply so we take our little cosine and secant and stuff, just like dip.
I mean, we could.
Now look,
What's 1 minus cosine squared?
sine squared.
It's sine squared. We just did that up above. I would start that by replacing that.
Okay.
So that instead of having that 1 minus cosine squared with two terms in there, we can just replace that with a sine squared. We're simplifying that down to that single term. So put that over 1 so we can multiply these fractions. Now what?
We can multiply our sine secant,
Mm-hmm.
and that would look like sine times secant multiplied by our sine squared theta over 1. Would that look weird? No. Then you could go on by looks. No, I know. If you do the sine squared theta over 1
Would we have to go down, would we have to make the secant something else? Would we have to-
Eventually, yes, we could do that right now, or we could do it in the next step, but we could also, because what we're gonna end up having here is a sine squared over sine.
Oh, yeah.
Okay, if we had like x squared over x, that's going to cancel out an x. So sine squared over sine will cancel out a sine, it'll cancel out the denominator, and one of those. So that gives us secant times sine.
Oh, that makes sense.
And what do we make it into a cosine?
So then we'd want to do our secant, replace that with 1 over
Cosine?
cosine times sine. All right, so if we have 1 over cosine times sine over 1, that becomes 1 fraction. That is sine over cosine, which is tangent. Very good.
No, I don't know, say anything yet.
Okay, give that fourth one a try.